Today we're discussing Kadane's algorithm. The first question that you're probably asking yourself right now is, what is it? What's the purpose? So the objective of Kadane's algorithm is to determine the maximum number that you can obtain from any subarray. And today we're discussing the high-level steps for Kadane's algorithm. And then afterwards, we're going to be implementing this problem by hand. I've also included some code right below so you can download this on your own computer and you can run this. Let's get started. So the big picture here is to loop through each number in your array and keep track of two pieces of information. The first piece of information that you care about is the running total. The second piece of information that you care about is the best sum. So track total and best sum. So as you're looping through each element in your array, these are the three steps that you can do to implement Kadane's algorithm. So the first step is this. When your running total is less than 0, so when it's negative, you no longer need that information. It's no longer advantageous to hold on to a negative number, and then you can set the running total to 0. So if you think about it this way, it kind of makes sense. If you have a running total that's negative, it's no longer going to be adding to that maximum, and therefore you don't need it. So to express this with code, we would write this. So step 1, if total is negative, then total is equal to 0. So very first step for Kadane's algorithm. The second step is this. Every single time, you're going to be updating your total by adding your current number. So keep in mind, you're looping through, right? So whatever your number you see, you're going to be adding that to your total. So step 2, total is going to be equal to, so we do plus equal to the current number that you observe. Perfect. And then step 3, every single time you're going to need to update your best sum, right? So if your total is bigger than your best, that means you need to update your best. Expressing this with code, we can write this. So we'll do best is equal to the max of our current best and our total. So these three steps that we have here are what we can use to implement Kadane's algorithm, and we're going to be using these steps on this problem over here. So we're going to do this problem by hand. So the very first thing that we need to do before we loop through this array is that we need to write down the variables that we're keeping track of. So we'll have the total, and then we're going to have the best number or best sum. And because we're trying to find the maximum for any subarray, I'm going to initialize my best as negative infinity. So you may ask, why negative infinity? Keep in mind, we're trying to maximize, right? So any sum that I get is guaranteed to be larger than the smallest number that we can have possible. And that's why I choose negative infinity as the initial value for the best. For the total, we will set this to 0 because in the very beginning, before you loop through, you haven't added anything. So you can have 0 as that initial value. So let's get started. The very first number that we have is negative 2. Step 1 over here says you want to look at total and see if that's negative. If it is, set it equal to 0. Our total is equal to 0 right now. It's not negative. Therefore, I don't need to do anything with it. The next step says we're going to take our current number, which is negative 2, and then add that to 0. So we'll do 0 plus negative 2. When I do that, that gives me negative 2. Next step says you want to find the maximum between the best, which is negative infinity, and then the total, which is negative 2. Well, negative 2 is larger than negative infinity. Therefore, we're going to update our best as negative 2. Perfect. So that number is done. Let's go to the next number, negative 3. Is the total negative? Yes, it is. We have negative 2. Therefore, we're going to set that equal to 0. So set negative 2 equal to 0. Set total, I should say, equal to 0. All right, next step. Take the total and then add that to our current number. Our total 0, current number is negative 3. Therefore, we'll do 0 plus negative 3. And that gives us negative 3. Next step, we want to find the maximum between our best and negative 3. Well, negative 2 is larger than negative 3. Therefore, we're going to keep best the same. Next number, we have 4. Is our total negative? Yes, it is. Because of that, we're going to set our total equal to 0. Next step we have is to take our total, which is 0, and then add that to 4. 0 plus 4 is going to give us 4. Next step, you take the max between your best, which is negative 2, and to 4. When you do that, you're going to get the value of 4. And by the way, do keep in mind one thing I want to chime in here is that whenever you have your total is 0, that indicates the beginning of a subarray. And then whenever you update your best, that indicates the end of a subarray. So keep that in mind. Right, let's move on to the next number. We have negative 1. Do we have a negative for the total? We don't. So move on to the next step. We take the total, which is 4, add that to negative 1. 4 plus negative 1 is going to give us 3. Step 3 is to take the max between 4 and 3. 4 is larger, therefore we keep best the same. Move on to the next number. We have a negative 2. Is the total negative? It's not. Therefore, we can keep this as what we have. Step 2 says you want to take the total, which is 3, and then add that to our current number, which is negative 2. And I need more space, so let me erase this. We're going to have 3 plus negative 2, which is going to give us 1. Step 3 says you want to take the max between your best, which is 4, and 1. 4 is larger, therefore your best is going to stay 4. Next number, we have a 1. Let's see, is the total negative? It's not. Go to the next step. You take your total, which is 1, and then add that to 1. 1 plus 1 is equal to 2. Step 3, you find the max between 4 and 2. The max between 4 and 2 is 4. Therefore, your best is going to stay the same. Move on to the next number. We have a 5. And let's see. Is the total negative? It's not. Move on to the next step. We'll take the total and then add that to the current number. So total is 2. Add 2 and 5. And 2 plus 5 will give us 7. So that's what we have for the total. Next, we're going to do the step 3, which is taking the max between our best and the total. As you see, our total is larger. Therefore, we need to update the best to be 7. And then the last number that we have is negative 3. So let's see, is our total negative? It's not. Skip that step. The next one that we have is to take our total, which is 7, and then add that to negative 3. So plus negative 3. When we do, 7 plus negative 3 will give us 4. 4 here. Third step, you find the max between your best and total. 7 is larger than 4, therefore your best is going to stay exactly the same. And then you're done. So keep this in mind. As you see here, we have a 7. What does this mean? This means that if you were to find every single possible subarray that you can have here, the largest value that you can have as a sum would be a 7. And we did this by using Kadane's algorithm that was described by these 3 steps.